Hi, everybody. This is Gigi Drent from Kauai Community College. In this video, we will use truth tables to determine whether two logical statements are equivalent. So let's get started. Okay, so truth tables and equivalent statements. Let's start with definitions, just to make sure we're clear of what we're doing here. A truth table tells us all possible truth values of a compound statement based on the truth value of the simple statements that are being combined to make up that compound statement. And you've seen that in the last video, right? Now, two statements are said to be logically equivalent when they have the same truth values for all possible combinations of truth values. Okay, so let's take a look at questions like this. Are not P or Q implies Q, and the statement P or Q of equivalent. So you have two statements there, and the question is, are they equivalent? Well, let's see about their truth values, okay? If the truth values are the same for all combinations, then we say, yes, they are equivalent. Here in this statement, we have P and Q, and that's it. Those are the two simple statements. And we know if we have two simple statements, we have four combinations of truth values. True, 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 false, false, true, and then false, false. Okay? Then when we look at this statement here, we would say, well, order of logical connectives will apply. So I will have to go not P first, and then not P or Q next. And then the last thing would be the entire statement. Okay, so that's the first statement. Let's deal with the truth table for that first statement. And then we're gonna look at the second statement, P or Q, and see if they are equivalent. Okay, so not P means the opposite truth value of P. So we have false, false, true, true. Now, not P or Q. Okay, so we're looking at the connective or. Now, when we have or, then we would say, remember, it's an inclusive or. So either one is true or both are true, okay? So we would look at the third and the second column. False true is true. False false is false. True or true is true. And then true or false is true. And then the entire statement, we are looking at the if-then connective. So we'll have to keep in mind the truth table for the if-then statement. And we are looking at the fourth column and the second column, right? So true implies true is true. False implies false is true. True implies true is true. And then true implies false is false. So now we would look at the other statement, P or Q, right? Now, if they have the same truth value for all of these corresponding combinations, then we would say that they are equivalent. Okay, so let's remember P or Q. Or is the inclusive or. So true or true is true. True or false is true. False or true is true. And then false or false is false. So when we take a look at the combinations of truth values, we would say they are logically equivalent. okay? And that's what it means to be equivalent statements. All right, let's take a look at another example. So suppose you have this statement here and this statement here, and we want to know if they are equivalent. So again, order of connectives will apply, okay? And since we have 3 simple statements, P, Q, and R, how many choices of truth combinations do you have? Okay, so P has 2 choices, Q has 2 choices, R has 2 choices. So 2 times 2 times 2 is 8. You have 8 different combinations to list there. Okay, so let's go and slowly write them down systematically. True, true, true. True, true, and then false. True, 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 false, and then true, and then true, false, false. That's it for when P is true. Now let's look at when P is false. You have false, true, true, false, true, false, and then false, false, true, or all of them are false. So those are all the possibilities that you could have, right? So order of connectives apply. P and Q first. So true and true is true. True and true again is true. True and false is false. True and false is false. False and true is false. False and true is false. False and false is false. And then false and false is false. And then the next thing we're going to look at is the 4th column that we just did together with R. So we're looking at this one and this one. And the connective is OR. Okay, so OR means an inclusive OR. So you have true, 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 false, or false is false, true, false, true, and then false. And that is it for the first statement. Now let's deal with the second statement. We have parentheses there because that's an ambiguous case, right? The and or are in the same order. So you have to use a grouping symbol to really say what you mean. In this case, we would apply the Q or R first, and then this statement combined with the N second, okay? So Q or R. So we're looking at the second column and the third column here. So true or true is true. True or false is true, true, and then false, true, 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 and then false. You may pause this video as often as you like to make sure you are following, because I know I'm going pretty fast, but you have that capability to just mute me, okay? All right, now we are looking at the blue column that we just did and the first column. So this one and this column. And the connective is and. Okay, so and means both has to be true in order for it to be true. So true, 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 true and false is false. And then false and true is false. Wait a minute. All of these first 4 checked out, but then this one is true and this one is false. So we don't need to go any further. You know that they do not have the same truth value for all possible combinations, because here is my example of when they do not work, right? When they do not match up. So we say, oh no, that's it. They are not equivalent. And the sign for that is like a triple line and then cross. That means not equivalent. Okay, and that is it for today. Let's practice some more in your written assignments and make sure you post online if you have any questions. That's it for today.